So we are going to solve radical equations. So we've been doing a lot of different things with simplifying radicals the last few days. Today we're going to look at equations and solve them. So solving a radical equation, you can square both sides of an equation and the resulting equation is still true. So one of the things to remember is why we're doing these is that whatever you do to one side, you have to do to the other, and you can do basically anything you want to both sides of the equation, as long as you do it the same way to both. Right? Okay, so here we go. Example 1. Basic radical equations. So, how do I get rid of a square root sign? The magical question. How do we get rid of a square root sign? Okay. Well, to get rid of a square root sign, you square that side and the other side. All right, raise them to the second power. Okay. So these two things undo each other, the square root and the squared. So we get x left on the left-hand side and 25 on the right-hand side. And it's going to be very important that while you're working through these that you do check your answers. Okay? I am going to expect that you do on quiz and test. So square root of 25, does that equal 5? And the answer is those are both the same, so it checks. All right, you have not completely checked your answer unless both sides of the equal sign are the same. Okay, and that's going to be very important as we move farther into this. All right, these first couple, should be pretty simple, pretty basic what you're doing. But when we get into the last couple of examples we're going to do today, it's not quite the case. All right, you're going to need to check your answers. And we'll talk about a shortcut too, how to look at it to guarantee it. So, okay. So letter B, we have just a radical here, number over here, so we're going to square both sides. So you get 100 equals 2x. Divide by 2, x equals 50. Oops. Yeah. All right. Okay, let's do 150 of those.
No, it's not. Say again.
All right, so do letter B. Now, what do I do if I have more than just a thing under the radical on one side of the equation? Well, if that happens, then we actually end up in this situation just like number 1 here from our warm-up. Okay. What did we do first here? We got rid of the 5, right? Because we wanted to get the x by itself. Well, same thing happens here. We want to get the radical by itself. So our first step, number 1 thing we're going to do is isolate the radical. Okay. Get it by itself. So if there's more than just the radical on one side, you need to get rid of those other things first of all. So we're going to add 4 to both sides first so that we can get the radical by itself. Once we have just the radical then on that one side, then we're going to get rid of the radical symbol by squaring both sides. So we get x equals 9 squared, or 81. All right, so our first step is always going to be to isolate the radical, get it by itself. Whether that means to add or subtract, or in the next example, multiply or divide to get rid of anything else there, or both. Right. So, square root of 81 minus 4, does that equal 5? Square root of 81 is 9. 9 minus 4, does that equal 5? Certainly, 5 equals 5. So it checks. Okay. Very important to check them. Make sure you are correct. Whether it's with on your paper, with your calculator, one way or another, you need to make sure you check your answers. Okay. Square root of 3 equals 7. All right. So, is there anything outside the radical on that side? No. Okay. So then in this case, we're just going to square both sides again. Okay. Since there's nothing else there, the radical has already been isolated. It's by itself. So we need to get rid of that radical symbol by squaring both sides. And then we can get rid of the 3. Okay. So I check it. Okay. Make sure you get the right answer. What if instead of positive 7 there, it said negative 7? So if I put a negative 7 here, when I square negative 7, what do I get? Okay, we get 49 still. Okay, if I subtract 3, then I get 46 still. So I put it in here. Okay, but if this was a negative, would the answer of 46 be correct? Okay, it would not be. Okay, all right, because obviously this is a positive 7. So you have to go by whatever that symbol is in front of it, okay, to make it work correctly. All right. Yep, this is. Let's see you do. Okay. Subtract 6. So we get square root of 5x plus 1 equals 4. Square both sides. 5x plus 1 equals 16. All right. Subtract 1. 5x equals 15. And then divide by 5. We get x equals 3. A little bit harder to check it. Let's use our calculator for a second to check it. Okay? Let's pull that out and see if we can check it with our calculator. Square root 5 times 3 plus 1, arrow over, plus 6, and that equals 10. Okay? So I plugged it in using my calculator exactly as it's written. All right? Get it right. Now you need to be careful. You have to use parentheses. You have to close the whole part under the radical in parentheses. So you would have a parenthesis here and after the 1. Okay? TJ. Did you extend it over before you hit plus 6? Okay. Put an arrow. Oops. All right, so I got the 5 plus 3 times 3 plus 1, and then I'm going to hit the arrow key so it takes it out from underneath the radical. Okay? And then plus 6. All right, good. Okay. All right, how about if we have to multiply and divide? Okay, so remember, we have to isolate the radical. Lucas, what do we do first then? Divide by 4. Because the 4 is on the outside of the radical. So we get square root of x equals 8. And then we square both sides. We got the radical by itself. We get x equals 64. Okay. Good. All right. Isolate the radical still, whether that's adding or subtracting or multiplying or dividing. All right. So do this one. Multiply by 2 first. 12 equals square root of x. Square both sides. And x equals 144. Okay. All right. We're going good. All right. Oh, okay. Here's the first big curveball. I have a radical on both sides. Or if I have 2 radicals. All right. So new situation. All right. Square roots on both sides. Or more than 1 radical. If you have 2 radical signs or symbols, your first step is to make sure they are on opposite sides of the equal sign. Oh, hey, that's a bad cue. Right? Opposite sides of the equal sign. Right? If they're on the same side, you're going to get into some major difficulties that you don't want. Okay? So if you have two radicals in your equation, you want to make sure they're on opposite sides of the equal sign. All right, so first of all, we look at letter A. Are they on the opposite sides of the equal sign? Yes. Okay, so then once they are, our second step then is to square both sides. Right? If they're on opposite sides of the equal sign, then we're going to square both sides. Get rid of the radicals. So the only thing is now is we end up with an x sometimes on both sides of the equal sign, which you know how to solve them, right? Okay, so finish that problem. Once you find your answer, all right, we subtract x. All right, so we get 8. Now, when you have, so far when we've checked our answers, they've simplified out to just a constant. Okay, it's been easy. Okay? In this case, when we do it, we check it. We get the square root of 2 times 8 minus 1 equals the square root of 8 plus 7. Okay? So 16 minus 1 is 15. So we get the square root of 15 equals the square root of 15. Okay? That's all right. They check. As long as both sides are the same, it worked. Okay? Now, here's our situation. We've got two radicals again, but they're on the same side. So the first step I've got to do is to move one of them to the other side, because we want them on opposite sides so we can square both sides. Now, here's the thing. Could I do this problem by leaving them both on the same side? The answer is yes, you could. The problem is, this is what you would get. All right? So watch. And be amazed and then be like, ooh, that's ugly. All right? So I square both sides. All right? So this is what I get when I square both sides. Now, how would you like to FOIL that?
Might be a little hard.
Okay, so if you leave them on the same side, you have to FOIL that. Is that hard? Actually, it's not. It's this right here. All right, see, that's not hard. That's what you get when you square both sides. Okay? Okay. Obviously not something you want to mess around. Because what I would have to do now then is I have to square it again eventually. Okay? No fun at all. We're not going to do that. So very important that you get the radicals on opposite sides. So we'll add square root of 6 to both sides first. Oh, much easier if we do that then. Okay, all right. So we're going to add the square root of 6 first. So we have the radicals on opposite sides of the equal sign. Then we can square both sides. Get 5x minus 4 equals 6. Much nicer, much easier thing to solve than that gobbledygook that we would end up with if we didn't get them on opposite sides. All right, so we add 4, 5x equals 10, divided by 5, and x equals 2. All right, make sure you check it. Square root of 5 times 2 minus 4 minus square root of 6, does that equal 0? Okay, very important you check it. 5 times 2 is? And 10 minus 4 is the square root of 6 minus the square root of 6. Is that equal to 0? And yes, it is. So it checks. 0 equals 0. Okay. Now, what if that would have been a plus square root of 6 instead of a minus square root of 6? Okay. We would have ended up with square root of 6 plus the square root of 6 here. We would have still ended up with 2. All right? That still would have been the case. But we would have had square root of 6 plus square root of 6, definitely not 0. Okay? And there would have been no solution there. Okay? All right? Okay, here we go. Last example. Now, I am aware that I have some very smart students in my room. Okay? So I want you to think for a moment. Okay? We're going to really do this problem, but you could really not do this problem and have the right answer. Okay? I could write a sentence and say the answer is this and because of why. All right? So take a moment, look at the problem, and see if you can figure out why I don't need to do anything and I have the answer. So if I take 12 plus a number, it has to be greater, right? So if I take 12 and I add to it, can I ever get 6? Absolutely not. Okay? So because this says 12 plus some number is equal to 6, there's no way that this is going to be negative because the square root of 6x must be a positive number. Okay? So let's do the math to prove it. Okay? All right, so we subtract 12 from both sides because we got to isolate the radical. So we get the square root of 6x equals negative 6. Okay? And here's where the problem lies right there. Okay? Everybody take out your calculator. Take your calculator. Go to your y equals on your calculator. And type in your y equals the square root of 6x. And graph it. Or look at the table, both. Look at the graph. Hit zoom 6 for your graph. Okay? And then look at the table also. Okay. Do you ever see any negative numbers? Okay? All right. There are no negative numbers. All right? Square root of 6x cannot equal negative 6. All right, so let's continue this. So I square both sides. I get 6x equals 36. Okay, that's legit. I can handle that. 6x equals 36. Remember, when I square a negative, I get a positive. All right. We divide by 6, and we get x equals 6. Great, I got an answer. Okay? The only problem is, it's wrong. Okay? This is what we call an extraneous solution. Okay? It's an answer I get when I solve the equation, but when I go back in to check, it doesn't work. Okay? So if I check my solution now, 12 plus the square root of 36 equals 6. 12 plus, square root of 36 is 6. And 18 does not equal 6. Okay? Never does, never will. So my answer is no solution. And the sentence that I told you before would be, if I take 12 and I add to it, I can never get 6. Okay? That square root of 6x must always be a positive number. Okay? Now, you graph the square root of 6x, just graph the square root of x. Okay? Graph the square root of x. There's zoom 6. Okay, all right. Starts at 0 and goes to the right, correct? There is nothing over here on the left-hand side where x is negative. You cannot take the square root of a negative number, so we can't get these. These will be no solution. If I look at my table, all right, if I look at negative numbers, all it says is error because we can't take the square root of a negative number. Okay? All right. Okay, we got another one here. B x equals the square root of 2x plus 3. Not the same situation, but still we're going to see where there's an extraneous solution to this problem. Okay. I have one radical. It is isolated. It's by itself. So now we need to square both sides. I have x squared. That means I have a quadratic equation, which means when I have a quadratic equation, I want it to be equal to 0 so that hopefully I can factor. If I can't factor, then I'm going to have to go all the way back to the quadratic formula or completing the square and do those things which you probably don't remember. Okay, maybe you do. Hopefully you do. Okay, all right, so we're going to subtract 2x and 3 from both sides. So we get x squared minus 2x minus 3 equals 0. Subtracting 2x and 3, negative 3 from both sides. All right, so we have a quadratic equation equal to 0. Now we want to factor. So x minus 3 and x plus 1. Remember, the factors of negative 3 that add up to negative 2. So x equals positive 3 or negative 1, right? The opposites. Positive 3 or negative 1. But we need to check our solutions. Okay? Now, let's go back here again. Look at my graph. How many negative answers do you see for y? Absolutely none. Okay? How many x values do you see here that are negative? Absolutely none. So if I put negative 1 in here for x, can that be possible? And the answer is no. Okay? All right? Negative 1 cannot equal square root of 2 times 1 plus 3. All right? It cannot, because this is a positive number here because there's no symbol in front of the radical, which means it's positive, which means the right side has to be positive. It can't be negative. So negative 1 cannot be a solution. So the answer is x equals 3. And you should check 3 also, but it does work. Okay? So sometimes, all right, we have no solution. You must check your answers, and this is exactly why with these two problems here. Okay. So be very careful with them.